In this discussion, I'm going to introduce the concepts of the Munsell color system and the natural color system. Combined with the Itten color system, those three systems are the most predominantly used color identification and organization systems today. And in your color studies, color management, and color practices, you will encounter at least one on a regular basis, if not all three. So let me preface first by talking about types of color systems. If we've bought paint, obviously the various paint companies have a way of classifying and organizing each of the colors that they manufacture. If you're familiar with Pantone, that is its own color system. Toyo Ink is a related color system to Pantone. There are digital color systems. There are analog or pigment color systems. Any color system can be one of three types. It's either a color notation, where colors are identified through codes, matching, which would be a swatch-based, such as Pantone or Toyo, and that would also include your paint colors when you buy from Dunn Edwards or Sherwin-Williams. And then there's the color selection, which is by attribute, and that would be the hue, saturation, luminance, the C-Lab, and the Itten 12-hue system. So the three systems that I'm going to address here are the 12-hue Itten system, the 10-hue Munsell system, and the natural color or NCS system. So let's look first at the 12-hue system. We know that with Itten that he identified colors based on location on a hue circle and also via their attributes or properties. So he identified within each color, it belongs to a hue family, it has a certain degree of lightness or darkness and a certain degree of saturation or dullness. He classified his hues into primaries, secondaries, and tertiaries, and also allowed for intermediate colors, which can be broken out of the 12 hues. And his system is a naming system, and you should be very familiar with this if you've worked with the Itten 12-hue system for a time. So we know that yellow, blue, and red are the primaries, and then the secondaries are mixed from the two primaries, orange, violet, and green. And then the 12 tertiaries are mixtures of the primaries and the secondaries. And there is a standard sequence, a natural ordering of the hues, and everything is at full saturation, although not the same value. Itten also identified 7 different hue contrasts which work concurrently. So the contrast of hue, the visual difference, say, between yellow and yellow-green would be the amount of blue that's in yellow-green versus the amount of yellow. The direct contrast of complements, the indirect contrast of simultaneous, which both complementary and simultaneous deal with the afterimage effects. The extent or proportion of a color. Temperature is the warmth or coolness of a color. Intensity, of course, is saturation. The value is the lightness or darkness. So Itten propounded a color sphere out of which he derived a color star and the flat hue circle. So the color star is basically taking one of the poles of a sphere and extending out around to each of the 12 hues and their tints and shade possibilities. So the fully saturated color is kind of halfway out from the center, and tints move in toward the center in this, and then shades move away from the center. So the idea in the Itten system is that the 12-hue circle is a flat shape that's basically condensed from the color sphere, but color actually exists in a three-dimensional model. So Itten's color sphere looks like this. From one point of view, we can see yellow, yellow-green, green, blue-green, and going the other direction, yellow-orange, orange, and red-orange. And the shades are at the bottom. The tints are toward the top. And looking at it from the opposite point of view, we have violet, red to red, and then back at violet again in the center, and then blue, violet, blue, and then blue, green. And this is a diagram of, say, the blue hue and its tonality going toward the achromatics which form the core. And you can see there's an achromatic there. And then the hue circle basically runs around it with its tints rising to the top of the globe and the shades falling away toward the bottom. Itten also proposed 3 aspects of color study in the way that artists and designers use color. Impression is the physical, scientific idea of color, and that's the absolute understanding of color. Albers' theory of color relativity would fit in the impression zone. Expression are the psychobiological aspects of color, the effects of color on the human being, both physically and psychologically. And then construction are the meanings of color, the symbolism, cultural meanings, so that when we use color in communication, then that's where construction comes in. When you're trying to communicate trust, you're going to use a dark blue in Western culture. In Eastern culture, in Asian cultures, you're going to use red for good fortune and wealth and prosperity. It's the construction aspect that varies culture to culture. The impression and the expression are both more on the absolute side, both more on the, shall we say, provable or scientific side. So the 12-hue system specifically deals with pigment or colorants. So it is a subtractive system. It follows and supports the concept of the after image. There is a color sphere or color solid, and it's basically a color selection system by name. So the Munsell system is a 10-hue system. And Munsell's goal was to get rid of what he considered the arbitrary color names and instead use a notation system that would specify specific colors and hues by various codes. So you could always identify an exact color, and if you were talking about an exact color, you didn't have to break it down in terms of its component parts. You just handed over a color code for the color that you wanted. So he also has a hue circle. In it, there are 5 primaries, which are red, yellow, green, blue, and a purple, and 5 secondaries, which sit in between. And you'll notice that cyan sits across from red, and magenta sits across from a green. In some ways, it has some additive understanding in terms of complementary relationships, but Munsell doesn't necessarily follow the idea of complements and neutralization via the complements. So the way Munsell breaks down is that there are 10 basic hue families, and each hue family has 10 hues. So we already have 100 colors that we're dealing with. I've said here that it can't really be used to mix pigment in the same way that Itten's can, although there are certain artists who do follow Munsell in terms of mixing pigment. And of course, when you're learning Munsell, it is a pigment-based study process. But it has a lot of additive ideas to it in terms of how the colors relate. Munsell was a little more interested in using color to communicate, and therefore was thinking of color in terms of getting exact matching of color for more commercial purposes, whereas Itten was much more, shall we say, artistically based. So in Munsell's notation, the hue is identified by a number and a letter. So the 5R is different from the 10R. The 5 red is different from the 10 red. And then he has yellow red 5 and yellow red 10. So that gets us into the yellow orange and orange. So the 10 red is going to be more like red-orange in the Itten system, and the 5 yellow-red is going to be more like orange. And then it's followed by value over chroma. So if we're looking at this notation, we're looking at the number 5 red, which is the hue, value number 4, and that is its vertical distance, and then its chroma is the distance from the core of the hue circle. So Munsell's system is also a color sphere in a way. It's a color volume or color solid. It's actually known as the Munsell color tree because it seems more like, there's a trunk and then branches of a tree for each of the hue families. and they can basically wrap around the center core. And in a similar fashion to Itten's color sphere, the achromatics are placed in the center. They basically make up the center pole, and lighter on top and darker on the bottom, again like Itten's. And then the farther out you go, the more saturated the color. So each one of these branches off the center trunk can be modulated out like this. Here is the fully chromatic color, and then it moves in toward tonality toward the center core. The idea with Munsell is that the more saturated colors, or the stronger colors, those that Itten would call more forceful, are positioned farther away from the central core. Tints are always up top, shades are always on the bottom, and tones are closer to the center core than the saturated colors. As in Itten's system, which talks about normal value, colors don't reach their maximum chroma all at the same value. In other words, yellow at maximum chroma in the Munsell is always going to be lighter than red at maximum chroma. And that is also true with Itten. Yellow's normal value is always lighter than any of the other hues on his circle. And here we look at various branches. We've got a blue-green, we've got a red, yellow, and we have a violet or a purple. And here is a three-dimensional physical model of Itten's color tree. Whereas Itten dealt with three properties, Munsell also dealt with three aspects of color, and he talked about hue that related to emotional content, value relates to informational content, and chroma relates to attraction. So chroma is basically the saturation, value is the ability to see the color, and hue relates to the strength of the color. Munsell is used with both direct light and indirect light, so it can be both additive and subtractive. It includes a color solid, and it is designated by color notation rather than color properties. And the last color system I want to address is the natural color system. The natural color system is similar to Munsell in that it is a color notation system, but it is much more expansive than Munsell's. The natural color system uses the color opponent principle. So the color opponent principle basically states that when we're receiving wavelengths, we're basically looking at red versus green, blue versus yellow, or black versus white, and anywhere in between all three of those. It still is in a way related to the trichromatic theory, which is the rods and cones fire off of the three additive primaries. The idea of opponent theory is that you have a vertical pole, black and white, and you have a north-south pole, say of blue to yellow, and an east-west pole, say of red to green. And a color can be mapped or charted anywhere within those polarities. And again, it's a color solid. It's a spherical volume idea. Color becomes defined by the amount of blackness, the amount of chroma, and the hue. So again, it's more value, hue, and intensity. But it looks at percentages between various colors. And as we look at the chromatic colors and the achromatic colors it uses, we can immediately recognize those four medial primaries that work between the additive and the subtractive systems. So the NCS was developed in Sweden. It is an international color standard. It is used across a variety of industries, from transportation design to fashion design. And every color can be specifically defined and described. It's a notation system. It's used to create consistency in color communication within manufacturing and commercial design. It's used by architects and designers and manufacturers and engineers, anybody who is involved in designating or specifying color, mainly for what we'll call commercial use. So the NCS is not well known within the fine art realm, and not as well known even within graphic design as it is within environmental design, manufacturing, and engineering. Instead of primaries, the NCS identifies 6 elementary colors, and these are colors that are perceived by human beings as being pure. Within those elementary colors, there are the 4 chromatics, yellow, red, green, and blue, and 2 non-chromatic, or what Itten would call achromatic, which are white and black. Every other color is described by its degree of resemblance to these 6 elementary colors. It's important to note that this is not a color mixing issue, it's a color perception issue that the natural color system uses. To specifically identify particular colors, it uses both a color circle and a color triangle. So a color triangle is kind of a subsection of the color circle, and it's a more detailed section of the color circle. The NCS also uses a 3-dimensional color model, and any color that we can perceive can be mapped within this color solid. NCS is mainly subtractive, and there are standard colors and there are non-standard colors. So colors can always be added into the NCS system, but they may not be noted as standard NCS colors. And any standard color is going to use an S prefix, and S, of course, is for standard. We're looking at the NCS hue circle and color triangles. And you can see how this is a larger version of this, which is the red section, but you'll notice the polarity red, green, and then blue and yellow, and then white at the top, just like in Munsell and Itten, and then black at the bottom, just like in Munsell and Itten. Here is a illustration of the color solid. So in NCS, the hue circle is exactly at the equator of the color space. As mentioned, the elementary chromatic colors are compass points in that flat circle, then with white at the top and black at the bottom. Every quadrant between 2 elementaries is divided into 100 equal steps, so there has some similarity to the Munsell system, but they're not exactly the same thing. You can see that if you have 100 steps between elementary colors, you're going to have a lot more color opportunity than you will with the Munsell system. And it is a notation system, so it's red, 90, blue. So this describes a cool blue that has mostly blue and about 10% redness in its perceived makeup. Remember that this is not via color mixing, this is how we see the final color. So here are the 4 chromatic elementaries, and of course white and black would exist at polar opposites in the center. You can see all the 10 different color families between the elementaries. A color triangle is a kind of a subset. It examines one color family that's derived from an elementary hue blend. It is considered a vertical section through the color solid. The base of each triangle has 100 steps of value from white to black. And the apex, or the outside reach, the outer reach of the triangle, is the hue at maximum chroma, also known as chromaticness. So this is what the color triangle looks like. This would be the pole, the center core, white and black. Black's designated by S. And you can see that we have tints and we have shades. There's tones in the center moving out to the fully intense saturated blue. And every one of these points, these intersections, is a notated position. And so we are looking at how color is specifically named and notated within the NCS system by virtue of its position. For example, this blue is a standard color, and it has 10% blackness and 50% chromaticness, and it is 10% red and 90% blue. And here is a color chart that is part of the NCS system. When you work with the NCS, you're dealing with pigments, but there's also an additive and subtractive blend. It has a color solid, and it's designated by color notation just like the Munsell. When you're working with NCS, a spectrophotometer is often used to measure exactness of color. Spectrophotometers generally measure wavelength frequencies. One of the most popular ones among visual designers would be Color Monkey. You hang it in front of your computer display, and it will measure wavelength frequency and give you exact colors that you're looking at on screen based on wavelength frequency. An NCS spectrophotometer will give you exact color notations, so it will give you the exact location of any color based on the NCS circle and color triangle.